Moving to number 32. Basically, it's about, let's say, acids and bases mixed together. إذا مذاكرين لما درسنا salts, we said that we might have something called acidic and basic salts, and you might have something called both acidic and basic salts. For example, if you have both acidic and basic salts, let's take an example. نفس الشيء مثل ما موجود بالسؤال CH3COO NH4. This is a salt that contains both a base and an acid. If we have this, because هيدول الاثنين, these two species come from the same source, they will both have the same concentration. Okay? لأنه بالنهاية CH3 COONH4 will dissociate into one CH3COO minus and one NH4 plus. So they will both have the same concentration. If they both have the same concentration and the Ka of the acid approximately equal to the Kb of the base, دغري منحط نفس الرول اللي بنستعملها للأمpholites, which is basically half pKa1 of the acid and pKa2 of the base. This is what we use very simply. However, what if in your solution you have the same, but they did not originate from the same source? So they have different concentrations. And what if they have different Ka and Kb? What to do? So before we start with number 32, we're going to explain what happens if you have in your solution a weak acid and a weak base. If you have in your solution a weak acid and a weak base, هوني هنشتغل in general before we move to the question itself, okay? So if I have in the solution a weak acid, like if I put in my solution, this is خلينا نقول extra, okay? If I put in my solution NH4Cl, you know that this will give you NH4 plus and Cl minus, okay? And if I have CH3COONA, which will give you CH3COO minus plus Na plus. Both of these are spectators. What I have in my solution is a weak acid and a weak base. Now suppose that the concentration of NH4Cl, sorry بس القلم شوي, it's not fixed today, equal to, let's give it any number, 0.1 molar. And the concentration of a CH3COONA is equal to, let's give it 0.2, okay, or 0.05. خليه يكون أقل molar. Okay, and we already know that the pKa of, let's say, Damon, you study the pKa of the acid, the pKb of the base, because the pKa gives you how strong an acid is, the pKb gives you how strong the base is. But let's say the pKa of this couple is 9.2 and the pKa of this couple is 4.75. Okay, let's do this is 9.25. خلينا ناخد نفس الشيء مثل ما عطين بالسؤال. So that is 9.25, 4.75. Now, if you look, the first thing that you notice is they have different concentrations. If they have different concentrations, ما فينا نقول pH equals half pKa plus half into pKa1 plus pKa2. You cannot. You have to establish a system that tells you either the base will dominate the reaction or the acid will dominate the reaction, or both of them, a reaction between both will dominate. So all the possible species, all the possible reactions that I have in my medium will be the following. Either the acid that is NH4 plus will dominate the system according to this reaction اللي كلنا بنعرفها. Okay? And the property that dominates is the Ka of the acid, because this measures the strength of the acid. Or the base, أكيد this will render the medium acidic. Okay, so your solution will be acidic. Or the base will actually control the system. Plus HO minus. And we all know the property that controls the strength of a base is basically Kb. انتبهتوا? Ka is used to measure the acidity, the strength of the acid. Kb is used to measure the strength of the base. And this will render the solution basic. Or a reaction will take place between the weak acid and the weak base. بالنهاية you have a proton donor and a proton acceptor. So there could be a reaction between them to give you the conjugates اللي هن NH3 and CH3COOH. And this is controlled. What is the property that controls this reaction? It's Kr. From Kr, you find خليني all the species, and from the species you establish the pH. Now, when do I know if 1 dominates, if 2 dominates, or if 3 dominates? So, if Ka of the system is greater than Kb of the system, وهون نحن أخذنا the factor that is 100. So if Ka is greater, كنا ناخده قبل 1000, but now it's 100. So if Ka is greater than 100 Kb, then مين بيكون الdominant بالسيستم? The acid, لأنه it has the strongest property. Okay? Then reaction 1 dominates or predominates. You can neglect the presence of 2 and 3, and the pH of the system, like I said, will be acidic because the acid controls the system. If Kb is greater than 100 Ka, then هوني فينا ناخد or equal, okay? It's okay. Then reaction 2 predominates. You can neglect 1 and 3, and you can say that they don't exist. They do exist, أكيد, but you can work under the assumption that they don't exist. And the pH of the system will be basic because the base controls the system. If, however, وهيدي the property اللي كنا نحن عادة ندرسها بالcase of a salt. If the Ka and the Kb are in the range of 100, okay? يعني the Ka is not greater than 100 Kb. Maybe it's greater than 10 Kb, okay? Or the Kb is greater than 10 Ka. Or maybe they are approximately equal. يعني the difference in their pKa's has to be approximately 2. If pKa1 minus pKa2 is 2 or minus 2, honey, I don't care about the sign if it's positive or negative, so take absolute value. Then establish Kr. Okay, all of these fall under the umbrella. خليني أقول إنه Ca is not equal to Cb. If Ca is equal to Cb and the Ka is approximately equal to Kb, لما بقول approximately equal, I mean the difference in their pKa's is a maximum of 2. دغري pH equals half pKa plus half pKa2. Okay, the relation that we put here, هي the relation that we wrote here. Okay, if Ca is not equal to Cb, you have to study these properties. You have to study these relationships to know which one. Now, go back to the given. The pKa is 9.25. The pKa is 4.75. To compare the pKa of the acid, you need the pKb of the base. مين البيس؟ CH3COO-. pKb of the base هون أكيد the difference in pKa and pKb. Okay, ما تغلطوا. The pKb of the base is basically 14 minus 4.75. It's very easy. We can always find it. So that is 9.25. Look. They have the same strength of acid and base. يعني the acid is considered as strong as the base لأنه ال Ka measures the strength of the acid, Kb measures the strength of the base. They have the same strength, okay, and different concentrations. This is when you go to the third option. You have to establish a relationship between Ka and Kb, and you have to follow the reaction that says then the system is controlled by the reaction NH4 plus CH3COO-. بنخليها double sided arrow, okay? NH3 plus CH3COOH, and it is controlled by the property KR اللي كلنا بنعرف نجيبها. Remember? You can find it either تخيلوهم على pKa axis مين ال stronger base مين ال stronger acid, do pKa يا large minus small or the small minus large according to gamma, or simply write KR. هلا نحن حنشتغله. Okay? KR هاترك فراغ بس to establish the table. Okay, and we will actually see this. Kr is equal to NH3 times CH3COOH divided by NH4 plus and CH3COO-. If you multiply this by H3O plus and divide by H3, and you basically multiply by 1, okay, you will notice that NH3, which is the base, times H3O plus divided by NH4 plus is basically Ka1. نحن سمينا ال NH4 is couple 1, true? Yes. So this is Ka1 times CH3COH divided by the conjugate and H3O plus. This is 1 over Ka2. So it is basically Ka1 divided by Ka2. So it's 10 to the negative pKa1 divided by 10 to the negative pKa2 كفو. So it is 10 to the power pKa2 اللي هي, which one is pKa2? This one. 4.75 minus pKa1, which is 9.25. What does that tell you? Nil value home, it tells you that this reaction is actually anti-gamma. It's in the anti-gamma direction, okay, because it's negative 4.75 minus 9.25. So it's actually 4.5. 10 to the negative 4.5. You can reach the same result إذا بتتخيلوا ال pKa axis قدامكم instead of doing this whole thing. However, we do need this. Why? Because we started with a value of NH4 plus أدينا قيناها 0.1. Initially, we started in a value of 0.1. Moreover, 10 to the power negative 45, it means that you keep this a double-sided arrow. The reaction is not complete, it's limited. Okay? And it actually favors the reactants حتى. So 0.1, 0.05, initially this was nothing. At equilibrium, this is 0.1 minus x, this is 0.05 minus x, x. Agreed? كتير منيح. منكفي ال KR يلي هي x squared divided by 0.1 minus x 0.05 minus x. By the way, إذا ما انتبهتوا إنه هن نفس ال concentration وما حطيتوا دغري إنه ال pH equals half pKa1 plus pKa2, هون حتنتبهوا when you put the same concentrations and you find x, you will find that both will give you the same pH. اللي هي half pKa1 plus pKa2. This whole value is equal to 10 to the negative 4.5, and here basically something times 10 to the power negative 5. I think it's 3.126 or 3.162, sorry. 62 times 10 to the negative 5. حتى ما حدا يضيع, this is it. Now find x. I prefer بهيدا الcondition that you don't neglect x. Which x? أي x أنا عم بحكي هيدا ال x. Don't neglect it. Even though you can, it won't give you that much difference actually. مش حتعطي difference الكبير. But try not to neglect it. Okay? Find x. X will be equal to 3. I think it's around 4. 3.976 times 10 to the negative 4 molar. Now, how can you find the pH? Use wherever you want. Use Henderson-Hasselbalch of either the first or the second. The pH is either equal to pKa1, which belongs to the first couple, plus log the base NH3, أكيد concentration, divided by the acid NH4 plus. وانتبهوا شو في حط محل ال NH3. NH3 is basically X. NH4 plus is basically 0.1 minus X. And at the same time, the pH has to be equal to pKa2 plus log CH3, Henderson-Hasselbalch of the second, divided by CH3COOH. Okay? CH3CO minus is basically 0.05 minus X, and this is X. Find both of them. Using both of these, you will find the same pH. It has to be the same. It's around 6.85. Do you still remember the derivation that we did لو وصلنا لل pH equal half pKa1 plus pKa2? What we did is that we did the summation of pH plus pH equals pKa1 plus pKa2 plus log the bases على acids. The only difference is that you could cancel the bases with the acids. Here they have different concentrations, so you cannot cancel them, which is why we do it this way. And this is how to find the pH of a system that starts with different concentrations of the acid and the base. Okay? And of course, I think in the question they ask you to find all the species present, determine the concentration of all the species present. It's very easy to calculate this concentration of all the species present. Eventually, what you can say is NH4 plus is basically 0.1 minus X. You find it. CH3CO minus is 0.05 minus X. You find it because you found X. And H3 is equal to CH3COH. It's equal to X. Great, you found it. What else do you have? How can you find the species that is H3O plus? It's 10 to the negative pH. Okay. How can you find the HO minus? 10 to the power pH, which is 6.85 minus 14. What else do we have? how can you find the concentration of Cl? Concentration of Cl هون it does not change. There was nothing consumed from Cl and nothing added to Cl. So the concentration of Cl minus هي بعدها 0.1. The concentration of Na plus بعدها 0.05. أكيد if no changes in volume happened. And this doesn't mention any volume. And that's it. That's all the species that you have. Okay. So in the question, اللي هو number 32, this is the given that you have. In number 32, they tell you that in 1 liter of solution, they put in part A, خلينا نركز أول شيء على part A, 0.1 mole of NH4 plus, عندكم إياها 1 liter, so that's 0.1 mole per liter. Okay? And 0.05 of CH3COONH4. So what is the concentration of NH4 plus in your solution and what is the concentration of CH3CO minus? خلينا نكتبهم. Okay? So in number 32, part A, you have NH4 plus is equal to 0. When I do this, you have to write the concentration. Okay? It's equal to 0.1. خلينا نكتبها. Okay. And CH3 COONH4 is equal to 0.05. هكتبهم بهالطريقة حتى ما نضيع. NH4Cl 0.1. Okay, let's say mole. It's okay. From this system, determine the concentration of NH4 plus and CH3CO minus in your solution. NH4 plus in my solution, here basically 0.1 that came from NH4Cl and 0.05 that came from CH3CO and NH4. And it's basically أكيد 1 liters, that means it's 0.15 mole per liter. CH3CO minus is 0.05 mole per 1 liter, so that's mole per liter. You repeat the same thing that we did right here, okay, with these new concentrations and find the pH. Now the pH should be, the pH that you find should be slightly more acidic, because now قبل شوي نحن كنا عم نستخدم, even though the pKa and the pKb are approximately equal, because the concentration of the acid, which was 0.1, predominated the concentration of the base, which was 0.05, you found that the pH is slightly acidic, 6.85. Now you will find it to be slightly more acidic. So this is your homework. You have to find this value.